Good evening, everybody. Very warm welcome to this evening's talk organised by BCS Mid-Wales. So warm welcome to our first talk of 2021. We are really pleased tonight to welcome Craig Watson, who is the Systems Engineering Manager at ForgeRock IT, and that's based in Bristol. Craig is a graduate of the Computer Science Department in Aberystwyth University, and after completing his course, he went into some initial roles that we might call traditional systems administration. Over time, he's become more involved with DevOps, and we're really pleased that he's here this evening to share his experience of what DevOps means for the way that he and his team works. We'll be taking questions at the end of the talk. You're very welcome to type your questions into the chat as we go along, and we'll get through as many as we can. But if you prefer to ask the question, you could raise your hand, which I think should be under your reactions option on the Zoom client that you're using, and then we'll come to you in turn as well. So a very warm welcome to Craig, and we look forward to your talk this evening, Craig. Thank you.
Thank you very much, Neil. Hello, everybody. Let me just start the slide deck. Awesome. So as Neil mentioned, I am a systems engineering manager within ForgeRock in the internal IT team. We're based out of Bristol. And as Neil also mentioned, I am a graduate of Aberystwyth. I graduated quite a while ago now, all the way back in 2010. And since then, I've been essentially kind of graduating through traditional systems engineering roles into more of a DevOps role, and now I'm actually broaching new territory in management at ForgeRock. My industry experience kind of ranges all the way through from very small kind of 100-person companies all the way through to ForgeRock, which is an 800-ish person company distributed across the world. We've got offices in San Francisco, Oslo, Grenoble, and two buildings in Bristol as well. As well as ForgeRock, I've been involved in public cloud consultancy work, which involved building and maintaining high-load, high-traffic websites for the likes of Liverpool Football Club, Superdry, Lush, among a few others. Away from the commercial side, I'm also an active Puppet community member. So I've been kind of a big fan of Puppet for a long time. I have contributed to PuppetDB, which is Puppet's internal node database. I've spoken at a few Puppet events, and I've also contributed some open source work into the Puppet community as well, via a few Puppet modules that I've written and published on both GitHub and the Puppet Forge. I'm also an av geek. I'm a controller on IVAO, which is a virtual flight sim network. I mostly control at Heathrow and Stansted. So if there's any fellow av geeks on the Zoom, feel free to drop by. Any activity is always welcome. So to understand really where DevOps originates, we have to kind of go back a little bit in time. And as the previous slide kind of intimates, I'm a heavy metal fan, so I'm going to kind of use a couple of heavy metal analogies and albums in the presentation. So a long time ago, we need to go all the way back to the kind of the genesis of systems administration, which is kind of this style of setup where you had entire rooms full of servers, or indeed an entire server which filled a room. So that essentially was what sysadmins were kind of trained to do. And that then graduated into physical server rooms, server farms, and eventually full-on data centers. So traditional systems admin work has been very much rooted in physical kit hosted in physical racks in physical data centers, which needed a lot of manual physical maintenance and care. That then gave way to the waterfall method of systems engineering and the waterfall method of application design. So you spent 6 months designing something, and then you spent 6 months writing tests for it, making sure that the code passed the tests. then 6 months writing documentation, doing QA on it, and then 6 months handing it over to your production engineering team to manage and deploy. This kind of throwing the application over the wall to the next team in line is essentially the technological equivalent of just throwing a grenade over a wall, which is the equivalent of just running away when after you've deployed your application. It's all ready, it's all packaged up, you've done all the testing, you've written all the documentation, you just throw it over the wall and run away. I haven't actually deployed anything like this myself, but I have heard horror stories of UK-wide applications that are delivered to the ops team on a USB stick on a Friday afternoon. Then the entire development team just ups and goes down the pub on a Friday evening and leaves the operations team to deploy it. That's the worst case. Obviously, there's edge cases, etc. So that method of deploying and writing and waterfall application design generally tends to result in silos. Now, these silos are generally aligned to your product team, who are they're the people who end up designing the application and laying out all the product features. Then it's handed on to the developers, who then go away and actually do the techie work and build the application. It's then handed on to your QA team, who then write the tests and actually work out if the developers have written something to spec. Then it's finally handed on to your ops team. And the key thing with this is that none of these silos talk to each other much. It's all done very, very officially via specification, via documentation. There's no cross-pollination of process, there's no cross-pollination of ideas. Or if there is, it is exceptionally little and exceptionally few and far between. That method of working then leads on to this kind of problem, where in production, if something happens, a developer basically looks at the code and says, that works fine on my machine. You've obviously deployed it wrong. So then there's there's a mistrust going on between operations and development. Is operations even reading the docs properly? Have the developers just not picked up a bug? This whole communication breakdown has a profound effect on the operational effectiveness of the application. From a systems engineering point of view, this is basically like riding a bike, except the bike is on fire, you're on fire, everything is on fire, and you're in hell. That's a very nuanced view of it, but this is as close to my personal experience as I can get of deploying an application in a standard waterfall environment where you've got no communication or real trust in the people who have written the application. And at times it is very challenging to be in that environment. Now, because that's a pretty heavy statement, I just thought I'd throw in a slide of a cute kitten. And because I have been Googling cute kittens, I can't help but put more cute kittens into another slide, because I like cute kittens. So that then brings me on to DevOps, which is just a brave new world in systems administration and systems engineering. This is where the majority of the talk is going to be. Now, when most people think of the word DevOps, they, in my experience, generally tend to think about the insane myriad of tooling that is available in the DevOps space. That extends to CI tools, it extends to infrastructure as code applications, cloud providers, CI and CD frameworks, and anything and everything in between. So the first myth that can be busted about DevOps is that it is not related in any way to the tooling. In fact, it's the inverse of this. So because DevOps is a collaboration and culture. The tools that you use are really a result of the collaboration and the thinking process that goes along with using all of these tools. So if we jump back to the tool slide, a lot of these and most of these tool sets are code-based. For example, Puppet, Chef and Ansible are examples of configuration management applications, which are they're a subset of infrastructure as code tooling, which means that as a systems engineer, you can use the functionality of code in order to express your systems config as a code base rather than a set of commands which you shell onto a server and run in order to take it from ISO into something that is production ready. So the idea behind configuration as code is the fact that it simplifies and codifies all of your processes, all of your documentation into a living code base. And because DevOps is a culture, it's a cultural mindset, we can then start using or borrowing a lot of methodologies, a lot of techniques from the software engineering side and bring those into system engineering. Now, DevOps is it's a mishmash of two disciplines, development and operations. So the communication and the culture kind of melding goes both ways. So you may have systems engineers like myself who have been trained and learning how to manage tin servers, bare metal servers, crossing into more systems development and infrastructure as code and configuration as code. But you can also have what is probably now termed full stack developers, who are essentially have a hand in responsibility for the entire stack of application infrastructure, all the way up from the OS, all the way to the load balancer, which serves content from the application. So the whole premise behind DevOps is that it is a culture shift from the old siloed mechanisms of kind of not having any communication with your developers, or the developers not having any communication with your operations team, to a living, breathing ecosystem where if a sysadmin has a problem with the application, they can just go over to the developers and say, hey, this doesn't look right. What do you think? And the whole conversation starts, and the two departments tend to work together rather than just booting things over a wall back and forth. So as I say, DevOps is really a culture shift and a mind shift of how traditional systems engineering is becoming far more application oriented and far more software driven. And as a result of the software driven side of things, we are now automating a lot of what we previously were doing manually. So I forget where I actually heard this from, but there is a well-known adage in the systems engineering and general automation industry, whereby if you find yourself doing the same thing 3 times, that thing should be automated. So for example, if you're sharing onto a server to add an SSH key, for example, or if you're deploying an application via a script, that script can be automated and abstracted away into something like Jenkins or GitLab CI or Travis. So we're using automation to really make sure that we're working smarter as systems engineers, and also as developers, and also as QA engineers, to make sure that we're not wasting our time doing the really kind of mundane, silly things. For example, as any systems engineer will tell you, we don't like managing DNS. Who graduates from university to just sit managing a DHCP and DNS server all day? Not many people. So we tend to automate these things away, put them in infrastructure as code bases such as Ansible, such as Puppet, such as Chef, in order to make sure that we can reproducibly deploy all of these applications without all of this manual human process. And manual human process is prone to human error, for example. So having things like your OS config and your infrastructure config as a living code base helps in ensuring that your application and your infrastructure is auditable, is templated. When your security team comes to you and says, why is this firewall deployed like this? You can just go and point to your Terraform code base and say that code base says it's configured in this way. So you don't have to kind of delve through run books or documentation to try and find out why something is configured in the way it's done. This is an example of Terraform, which is a infrastructure as code configuration language written and published by HashiCorp. In this code excerpt, you can see that there's a variable, there's a resource, there's a variable and there's two resources. One depends on the other. So if you look at the network parameter of the Google Compute subnetwork resource, it shows that there is a link between the subnet and the network. So that says to Terraform that it needs to create the network before the subnet. So you can immediately see having these kind of things in code means that it is far more reproducible, far more testable as a key part of your infrastructure. And as a sysadmin who has come through the ranks as a traditional tin sysadmin that has had to configure networks manually on switches and configure VLANs, and even in cloud providers, you may have had to set up your VPCs manually with subnet ranges that are kind of custom to you. If you start using infrastructure as code tooling and DevOps mindsets, you can very quickly and very easily start abstracting away all of that complexity and all of that responsibility. Because if your infrastructure's code base says that this is the state of your infrastructure, Terraform will just go ahead and apply that state. And this is one of the core foundations of DevOps for me. It is so powerful and also kind of very important to the underpinning of automation. And another example of the Terraform code base I previously mentioned, the code excerpts on the left and right are essentially doing the exact same thing. Because you're working in code, you can abstract away the cloud provider. In this instance, the left-hand side is doing something with AWS, and the right-hand side is doing something with Google Cloud. And the code excerpt at the bottom is essentially, it's a GCP specific loop, but it's looping through all of the instance attributes, all of the rich data which the instance provides, and then spitting that out as a key value pair in a text file. So you can really see how the software driven side of infrastructure design is really advancing our ability to spin things up, tear things down at a rapid pace. We can now spin up QA environments just using a templated code base. So we don't have to go away and rack a whole 2 rooms of servers anymore. We can create an entire network complete with subnets, complete with VPN tunnels, complete with load balancers, all from one single code base. And again, just kind of rewinding and setting the stage for this. Even 10 years ago, the infrastructure as code revolution was really only getting started. With the advent of things like Terraform and another kind of configuration in infrastructure as code tooling, it's making the DevOps revolution far more accessible to far more people. Because obviously you've now got systems engineers who are looking to expand their skills in development, and you've also got developers who are looking to expand their skills in systems engineering. So you can really combine the two with infrastructure as code. And all of the associated tooling. Let's not forget, there's testing that we can borrow from the software development world. So something that the software engineering community has been taken for granted for for a long time is testing. As a systems engineer, when you needed to do a test, you had to go into a server, you had to have an entire rack or entire server room just for testing kit. And to run a test, you had to shell into a server, you had to run a certain subset of commands, and you had to run your test manually. Whereas now, if everything is kind of in code and we're using software engineering tool sets and mindsets, that is so much more powerful because it opens up so many more opportunities to do things like CI testing your application infrastructure, not just the application itself. So what DevOps really is just this harmonization between IT ops. So that's your system engineering teams, even your frontline support engineers, your development teams, and your QA teams, to make sure that everybody is working together towards a common goal and everybody isn't just throwing things over the wall to each other all the time. And because all of this infrastructure and all of this application configuration and all of the system configuration is in code, it does mean that if your developers want to contribute to the code, they can do, because it's hopefully in version control, it's in Git. So if, for example, a development engineer has a specific problem with the OS environment, say they need an SE Linux flag added for their application, or they need a specific file added to your centralized logging configuration, the whole process is much more simplified, because if they're happy to make the modification, and you have kind of testing in place to make sure that no bugs make it to production, you can open up your code base and you can essentially crowdsource your configuration management code base across both your operations and your development teams, which is something that is really powerful. I have seen working in previous companies. Not quite as large as ForgeRock, but I have seen it in smaller companies where I was the only sysadmin in the company. And obviously my time was very precious as the only systems engineer responsible for the office network and also our AWS production infrastructure. So by opening up our tooling to the development team as well, I was able to just review pull requests rather than spend my time working out how to implement a specific change. And then made sure that developers could chip in, and I could also chip in to their development work. If there was a low-hanging ticket that came up to fix a very quick application bug, I could dip into the code, fix it, and then obviously pass it through the appropriate testing infrastructure and testing phases. So as a discipline, DevOps isn't necessarily a job title, it isn't necessarily a set of skills, and it isn't really a set of tools. But it's more of a mindset, and it's a very, very powerful mindset to have, and collaboration culture to nurture within your organization. So a few tips on implementing or working well within a DevOps environment. The first of which is really communication. As I previously mentioned, you can be a systems engineer that is looking to get more into development, or vice versa. Or you can be a systems engineer that doesn't necessarily want to do development, but is interested in managing your infrastructure via code. The best way to do this is to put your hand up and go over and ask your development team, hey, what do you do for your application testing? How is this tested? And ask in a open way, rather than kind of coming out thinking, right, I'm going to learn how these guys do it and take it apart. If you go in with an open mind and try and learn from the software development side, you can come away with skills that you can then implement and onboard in your own infrastructure as code architecture. The best way of doing this is introducing testing into your infrastructure as code bases. So at ForgeRock, we have a Puppet code base and we have a Terraform code base. Both of those code bases are CI tested via GitLab CI. And for every pull request and every piece of work that's done, we follow loose Git flow So we don't have the full-blown Git flow setup, but we have pull requests for every piece of work. We branch per request, and we submit our pull requests through GitLab and have them approved and peer reviewed. So if anybody's worked in system engineering, in software engineering, this should sound very, very familiar. It's a software engineering approach to systems engineering tasks, which then has the ability to really bolster up our opportunities to skill up as engineers, because we're learning new skills. We're learning how to do testing. We're learning how to write tests, which is an art form in itself. How to write good tests that really test boundaries rather than just verifying the code works. You can really go the extra mile and test that a code errors when it should do, which is testing that not all developers tend to do. So if you really want to, you can really push yourself on the testing side. But the key thing to remember is communication between your development and your operations and your QA teams is really, really important for a DevOps culture to coexist and to grow. With the communication comes listening. So, and being open while listening. So I've come across engineers, and to be perfectly honest, I've been the engineer myself who has asked a question without necessarily listening to the response. So one of the key things about kind of being open and being collaborative is being receptive to the ideas of your peers. So you may have a pet favorite scripting language. You may have a pet favorite configuration management utility. But when you're opening yourself up to questions, going out to your dev teams and asking what they use for a specific thing, for whatever reason, they may use Ansible to deploy their application into their testing environments, and you're using Puppet. So that then opens up a whole heap of questions. Why are you guys using Ansible? Is it because it does something that Puppet doesn't do? Is it because it does something better? Is it because there's just been no opportunity to cross and learn Puppet? What is there anything that Puppet can do that Ansible can't, for example? So the whole premise of being open and responsible when you're asking questions is again very important when you're trying to learn and trying to nurture a DevOps culture in your organization. The next tip I can kind of share is just to experiment. Unless it's in production, you should be empowered to experiment with new things. You can always experiment and develop new things and try new things. If there's something that isn't working quite right, you should be able to kind of look at the problem, riff on it, and come up with a workable solution. It's the open source, scratch your own itch kind of way of working, where if you see a bug, if you see a problem, if you see something that isn't quite right, because it's code and because we have all of the testing infrastructure, all of the testing mindsets that I previously talked about, it's very easy to test some things out, to create a testing environment with just one run of Terraform, for example, and try things out, try new tooling, try new approaches to testing, try new configuration management or infrastructure as code tool sets. And it's really just a very, very collaborative environment. So you can engage your development teams if you want to, say for the sake of argument, you want to test out migrating your public code base to Ansible. You can reach out to your development team who may already be using it and try and bring their stuff into your workflow, or vice versa. All building on the communication and the listening attributes that I've already kind of mentioned. Experimentation and just playing around is a large part of the DevOps culture. And finding a solution that works for your situation is also a key one, which requires experimentation. The last thing I really want to mention is don't panic. The DevOps world is very opinionated. It's very polarized in some quarters. Something I haven't actually touched on is the rush to containerization, which is it's a hot topic for me. So there are lots of opinions out there. There's lots of blogs. There's lots of talks. My voice is just one. So if all else, if you go out and read a specific blog, you don't necessarily have to implement everything as written. You don't have to implement the Agile Manifesto just to be agile. You can pick and choose which sides of DevOps, which sides of infrastructure as code to implement in your organization and to nurture in your team. So one of the reasons why I'm still in the industry is that I've had some very supportive managers and I've had some very supportive peers who have really kind of imparted and taught me that every opinion and every kind of every solution is important and every voice is important. So don't panic if you're just starting out with DevOps and you go to some documentation and it completely contradicts something you've already read before. That's okay. And what matters is your feelings about it. If it doesn't feel right to you, don't do it. If you want to learn more, do some more digging, do some more learning, and do some more experimentation on your own, and show and tell your peers. Something that we're very encouraged by at ForgeRock is we have regular Forge talks, we call them, which is an environment where anybody within the company-wide, from IT to development to marketing to HR to finance, anybody can come and show and tell about their chosen subject. Now that then permeates through the entire company to what used to be our team learning meetings once a week on the Thursday, where members of my infrastructure team come together and show and tell their own ideas. So I've done talks on Puppet in the past. I've done talks on Terraform, but also another member of the team has done talks on containerization and Kubernetes and Helm, for example. So there are lots of opinions out there. There are lots of tooling choices out there. Just because one person is using Ansible doesn't necessarily mean that you should or shouldn't. So every tool has its use, and don't panic, really. Yeah. So thank you very much for listening. I may have rattled through a few slides, so if there's any questions, I'll happily take them.
Thank you very much, Craig. Okay, so are there any questions? You could either type it or you could unmute and ask a question. Okay, well, I'll get us started then. So you talked about testing the configuration, and I'm just trying to, so I'm sort of familiar with, running the automated tests, doing stuff in a CI way. But could you give me some idea of maybe what testing the configuration through the infrastructure looks like? What sort of tests would you create there?
So there's loads of different ways you can do it. At ForgeRock, we do a multi-layered approach to testing. So we have, first of all, we have lint testing on the code, which tends to weed out bad smells like white spacing and variable ordering and generally kind of code style. Then you've got essentially code compilation testing. Is the code even valid syntactically? Does it compile? Essentially, it's compilation testing. So we do both of these for our Puppet code base and our Terraform code base. Our Puppet code base in particular is quite well tested. We have upwards of about 15 different server roles that are being configured out of the same code base, and each role is tested in isolation of the others. So we test compilation of, for example, our Jenkins Puppet role and our Confluence Puppet role and our Jira Puppet role separately. we do this just to make sure that when we upgrade or change one particular part of a code base, it's not breaking something across the board. If it is breaking something, we need to know what it's breaking. So we do in compilation testing both, and all of these tests can be run both locally on my development machine and also as part of our CI pipeline. In addition to the compilation testing, you can go further and do acceptance testing. So you can actually spin up automated environments, run the puppet code, check the output of the puppet code, and check that, for example, the files are in the correct format, check the content of the files is correct. And then you can go a step further on that and test the application deployment. So for example, with various other tools, you can actually run automated content testing on a load balancer, for example. So if it's a Jira application you're deploying, you can write a set of automated CI tests which go out and log into Jenkins, click a few buttons, and check that the application works. So you can really go all the way from does the indentation look right, all the way up to full-blown automated application testing, and even load testing as well. So it's really as much or as little as you really kind of want to do. As an infrastructure team at ForgeRock, we kind of stop at the acceptance testing layer. That's generally because we've got a couple of test environments that we use to test with. So our acceptance testing is done via our UAT, our staging environment, which is it's an elastic environment, so it means we can turn on and off applications as we see fit. But it's a standalone sandboxed environment where we run our acceptance integration tests. But depending on how much effort you put into your CI/CD pipeline, you can really go all the way from nothing ever gets to production until it's been through all of these different testing layers.
Okay, thank you. We got a question here on the chat. So how do you start with DevOps if your team is not very mature? Is that some living?
So it depends why. The answer really depends why you're looking to implement DevOps, or why you're looking to kind of to build into a DevOps mindset. If the team isn't necessarily that mature, then trying to add a bit of Agile over the top. So for example, weekly stand-ups, weekly show and tells, trying to get the engineers kind of interested in the whole process. Kind of trying to demo CI for your infrastructure would be a really good idea. It also depends which side of the DevOps culture these engineers are coming from. For example, if it's a systems engineering team that's trying to learn infrastructure as code, you can kind of lean on but you don't have to do manual testing anymore kind of mindset. Or you can lean on, well, we don't have to manage our database users anymore. We can just do them by code. And having the auditability from a management perspective, that really helps in terms of kind of stopping things getting to the engineers that shouldn't be getting to them. For example, when the ISO 27001 audit comes around, not having all of your engineers stuck in a meeting for 5 hours going through all of these ISO requirements. If your infrastructure as code is being done properly, you can either give excerpts of the code, or you can just give screenshots of the output rather than trying to tie engineers into meetings. So that's what I would say from the systems engineering side. From the development engineering side, it's really a case of if the initial appetite to get into the system side isn't there, there may be high-risk sysadmin. to kind of shore up skills in the area, because ultimately it has to be a personal thing. You can't. I wouldn't personally push anybody into a DevOps culture who didn't want to be there. And ultimately, if there's resistance, then that may well point to a wider team culture problem. Obviously, I don't know the team that's being mentioned, so I'm not entirely sure. But if there's reluctance to embrace the idea, people may have had bad experiences with DevOps in the past. Maybe somebody's used DevOps tooling at a different company and had a bad experience with that. So it's really taking the culture and the communication aspect, and maybe having an open forum where we ask the difficult questions, and we can kind of, in an open room, say, I as a manager, I as a leader would like to implement DevOps. What are people's feelings about this? And then have a wide open communication, and see what the answers are.
Okay, thank you. We've got another question here on the chat. So, I develop low-code solutions, Power Apps. In my experience, promotion to production with low-code is very hands-on process with many moving parts. And do you have any recommendations that could improve that?
I've not, to be completely honest, I've not heard the term low-code. I'm assuming that means kind of serverless. Almost a serverless architecture where there's no real code involved. It's just using compute. Trying to automate the deployment. I would, in taking it apart, I would take the deployment apart and look at each individual step in the deployment process, and work out what parts you can automate, what parts you can parameterize. Try and pick out the bits that are causing you the most pain, and come up with a solution. It could be that you turn a script into a Jenkins job with a button on it. It could be that you look into a different database abstraction layer that does migrations for you. It could be that you, instead of deploying it to App Engine, you deploy it into Cloud Functions, or if you deploy it into Elastic Beanstalk, there could be other tooling choices which may suit your use case better. But obviously, without knowing the code base that's being, and the tech stack that's being deployed to, I can't really make kind of tooling recommendations. But I would at least almost kind of break it apart to the point where you would come in at, if you're a brand new engineer looking at this project for the first time, looking at it from a complete everything on the table from scratch kind of way. If there's manual issues, if there's manual steps that need to be taken in order to deploy, then looking at why those manual steps are there. Are they there for data entry? Are they there because they've always been there and it's been designed like that? Are they there because it's been done like that once and we've never really gone back and looked at why? So really just, again, taking it apart, looking at each individual component and breaking it down to little bite-sized bits, rather than treating the whole application as an atomic unit.
Okay, thank you. So another question then is there any DevOps best practice which could be used in a commercial off-the-shelf software environment?
Yeah, basically the commercial off-the-shelf software, you're generally given a binary to deploy with COTS, and it depends on the application, the application architecture. For example, at ForgeRock, we deploy the Atlassian stack of Bitbucket, Confluence, and Jira, which is COTS. We just download it from Atlassian and install it. However, we do use DevOps culture and DevOps mindsets with, all of the infrastructure as code tooling, which underpins the OS. So, for example, deploying the application is just as straightforward as downloading the zip of Jira, unpacking it, and automating out all of the deployment steps. So just because a piece of software is COTS doesn't necessarily mean that you can't use DevOps tooling with it. It's all the tooling just moves from being in-house developed to in-house supported. So you can kind of abstract it up or down one layer to the OS rather than just the application. So you may not have control over the full application stack from the code base all the way down to the bare metal, but you can at least control in DevOps and kind of code out all of the issues underneath it. So for example, you can make your OS config reproducible. You can make your OS application kind of deployment resilient and redundant. So you can use the pets versus cattle kind of clustering analogy. Keep all of the data on a persistent disk and just whip the OS away if it has a problem, and just have the compute instance spun back up and kind of installed via your automation tech. If that's Puppet, if that's Ansible, if that's Chef, Salt, whatever. So just because an application isn't developed in-house, you can absolutely do a lot of DevOps, DevOps-like technology and DevOps-like kind of approaches with non-in-house applications.
Okay, thank you. Another one here. So how would you build in security to some of the DevOps approaches that you've mentioned?
Security is a big one. I can take it from the context of Puppet, which is the configuration management utility we use at ForgeRock. And you can DevOps, you can design out the security implications of the DevOps by making sure that all of your secrets, for example, database passwords, application API keys, all of your sensitive data is encrypted at rest in Git via things like KMS, which AWS and GCP, and I believe Azure also provide as a service. So for those who aren't aware, GCP and Amazon provide KMS solutions, which is essentially GPG as a service, which allows you to pipe plain text into an API, which gives you back ciphertext. Those cryptographic solutions can be locked down via identity and access management rules. So for the sake of argument, you can say that only your systems engineering team can decrypt secrets encrypted with your production key, for example. This means that you can expose your code bases without exposing your secrets, which is a key security constraint when working with cross-team infrastructure as code applications. So obviously, as a systems engineering team, you don't want to give your production database credentials to your developers, which would be a very, very bad idea. So using these KMS applications and even using plain old GPG keys, you can really encrypt your secrets at rest, which is the main security benefit. You can also, just because you're giving people access to your code doesn't mean you're giving them access to your infrastructure. So you can have your developers commit to your Terraform code base, but the deployment of and the running of Terraform against your production infrastructure in AWS or Google Cloud or Azure, that can be done via your systems engineering teams. So you can have devolved responsibility between committing to the code and then running and deploying that code. So that kind of mitigates another security aspect of what many probably conceive as Wild West style security, where because your developers have kind of commit access to your code repositories doesn't mean that they can actually deploy it. Even in the realms of full CI/CD, if you have branch protection in place, if you have approval matrices in place for your pull requests and merge requests, you can make sure you can make sure in an auditable way that nothing ever gets to master and nothing ever gets to production without jumping through several security and compliance hoops. First, you can have manual approvals to merge into master. You can have, once a commit is merged into master, you can then have a full CI/CD pipeline which relies on manual approvals at set stages. So you can have a security sign-off, you can have a compliance sign-off, and this can all be kind of built into your deployment pipeline, which is a complete reimagining of your application deployment. For example, if your security team needs manual sign-off on a change, you can build that into your pipeline, your deployment pipeline. So there's loads of things we can do to not make sure that DevOps isn't insecure. And that's actually, I should have touched on in the presentation, actually, it's a major myth behind DevOps, is the fact that just because you're using DevOps methodologies and DevOps technologies, it doesn't mean that your application or your infrastructure is insecure. If it is, it's bad design, not necessarily bad implementation by DevOps.
Okay. Another one here. How would you implement release gates pipeline when developing the code into multiple environments? Deploying the code into multiple environments using DevOps.
I'm not sure if I understand the question properly. The question properly, sorry. But if you're, I would probably say that if you're using CI and CD to deploy applications into multiple environments, you're kind of already in the DevOps mindset and in the DevOps culture, because you're using CI and CD. So I think in the context of the application, I think that's already valid. If you're talking about the underlying OS, the underlying architecture, you can use things like Terraform and CloudFormation, and I'm trying to remember the GCP version now, Cloud Deployment Manager. So you can use infrastructure as code tooling rather than or as well as configuration management tooling to make the underlying architecture of your application, the OS, all code-based and all DevOps oriented. So that's one approach I would take, is just to look at not just the application, but also expand it to the underlying architecture. And that architecture could be anything all the way out from installing a server in a rack, all the way up to deploying a Kubernetes cluster and deploying the application with Helm. So you can deploy, of course, you can deploy a GKE cluster manually in the cloud console, but you can also deploy it in a code architecture with Terraform or Deployment Manager. So there's loads of different ways you can do it, but I would personally focus on the underlying architecture, and that builds on my experience as a systems engineer, not necessarily as a developer.
Okay. There's a little extra that came in after you started there. So just to add to that question, so I'm asking about infra and app change quality checks. Does that add to the?
Yeah, I think that clarifies it. Yeah, no, I think in terms of infrastructure, I think, as I say, Terraform and some kind of infrastructure as code specific tooling would definitely help the because if you have your GKE cluster, for example, in Terraform, it means you can template it, you can stand up in different environments, and you can ensure that it's consistent across all environments, which is another major benefit of using infrastructure as code kind of tooling and techniques. You can ensure that your underlying application architecture, not just your application, is consistent across all of your environments, which will help shake out any infrastructure bugs as well as the application bugs as well.
Okay, thank you. All right. So another question then. So how successful has DevOps been in heavily regulated industries such as avionics and healthcare?
As I said, I've not necessarily been employed in any of those industries, but I have. DevOps is very successful in regulated industries as well. It all depends on the implementation. Having said that, so I think that there is a place for DevOps in any industry, but you shouldn't just take DevOps as a single entity. If you break DevOps and if you break Agile down into its constituent parts, you can pick and choose which parts you implement in your organization. And it's a great example from one of my previous companies, which was Red Bee Media, which is an offshoot of the BBC. I was working there from kind of 2012 to 2013. And because it's broadcast media, which is not necessarily massively regulated, but it's also massively uptime driven. So Red Bee handled all of the live transcribing subtitles for BBC and basically every TV channel. And as a result, it was very heavily change controlled. I joined as a systems engineer and wanted to try out a few agile processes. We're already trialing out DevOps infrastructure as code processes in a small way. But I was interested to try and bring the team together. So I suggested we didn't have to do everything. We didn't have to kind of start having sprints and planning meetings and breakdowns. We literally just started with a daily stand-up, for example, which is just a great way of kind of implementing something that is a change, and in an industry where change takes a long time. So you can't just go into a healthcare business or an aviation business and say, right, we're doing DevOps now. It has to be a very slow, considered process. And the best advice I could give is start small. So rather than taking your existing production environment and backporting it, I would find a project, make it a proof of concept for your DevOps environment, make it a proof of concept for your infrastructure as code, and then prove the technology by doing it, essentially. So I think there's a lot to be said for experimentation, and if an engineer thinks the idea is good, give the engineer the opportunity to develop the idea and to implement it. And then at least if it doesn't work, that's an absolutely perfectly acceptable solution. So if your section of the company or if your team isn't ready for DevOps, doesn't want to implement DevOps for whatever reason, that's a perfectly valid use case, and every technology, every approach has its use cases and has its strengths and has its weaknesses. So it doesn't necessarily have to be full DevOps. You can choose to implement whichever specific sections of it you need to or you want to.
Okay, thank you for that. So another question here then. So do you use Scrum at ForgeRock? And if so, what are your sprint durations? And then are they synchronized with developer sprints?
So I can answer this in two ways. ForgeRock as an organization, as a development development team, yes, we do use Scrum kind of within the engineering side of the company. In IT, we used to use Scrum. However, because we are because we're in IT, we are very reactive. So that just didn't work for us as a methodology. So we stopped doing official Scrum with a capital S, and taking line from what I've already said about kind of picking and choosing. We diverged the workflows for the frontline operations team and the infrastructure team, which I'm now managing. So within the infrastructure team, we are probably much more project focused than the frontline operations team. That gives us more scope as the infrastructure team to work in a more agile way rather than anything which is massively reactionary. So we've really kind of taken it apart, pick and choose what we want to work with. And then we're implementing, for example, daily stand-ups, monthly retrospectives, and basically kind of whatever part of Scrum or whatever part of Agile we feel as a team would benefit us. So we don't necessarily have to do the whole thing. We're just kind of doing the bits that we want to do. And as far as synchronizing with developer sprints goes, it's hard to synchronize developer sprints where there's at least 5 individual kind of teams of developers within the company. We're an 800-person company, which is pretty large. So even if we could, I don't think we would want to synchronize with developers. We've obviously synchronized with the rest of the business because we're a software company, so our product has point versions to release, so we're obviously in tune with the rest of the company in that sense, but we don't align our work with the rest of the company, because ultimately if something comes up and something's on fire, we have to just be able to drop everything and work on that. So strict sprints, not necessarily for us, but agile and the other agile processes and the other agile parts are definitely something that we work with.
Okay, thank you. So another question here then, how do we start implementing DevOps in an organization that has legacy applications using the waterfall methodology?
That's the $1 million question, really. How do you backport DevOps? The easiest answer is to get buy-in from the existing teams, the existing engineers. So it's much easier to start kind of implementing change where you've had buy-in conversations, you've had various conversations with people. Now on this subject, there's a book that I would absolutely recommend to anybody who's looking to effect any kind of organizational change, which is Agile Conversations. It's written by 2 former managers of mine, actually, Douglas Squirrel and Jeffrey Frederick. And in it talks about various different conversations you can have within your business to make sure that people are aligned on a common why. I'm not doing a great service at the moment. I'm forgetting the chapter names, but the book is a great tour through how to effect change within your organization and trying to build this trust within your organization. And that's the key thing I would say is trying to build that trust, trying to have the wider conversation with not just your developers, not just your systems engineers, but your middle management. Say we extol the DevOps virtues of being able to ship quicker with less bugs, and there's various kind of sales techniques you can use. But the key thing is to make sure it's an engineering first, an engineering led migration and change. Because ultimately, if you as a manager try kind of imposing change downwards as well as upwards, that's never going to work, because you're going to have resistance from both sides. So the real challenge is to make sure your engineers are on board. And if your engineers are on board and they're happy with it, then you can start kind of putting in place certain aspects like configuration management of the underlying application architecture. Like I've already said, say you have a large monolithic application, you don't have to go full DevOps and start deploying that with CI and CD. You can kind of take the underlying architecture and start backporting that into infrastructure as code tooling and infrastructure as code architectures and languages, so that you can then use that as leverage and justification for future change. So when the next major release comes through, you can then run it through your deployment. Rather than being a pipeline, it will probably be a deployment Gantt chart, and you can do it in 3 weeks, whereas you used to do it in 4 weeks. 1 week is an improvement, so you can then use that metric to justify the gradual move into DevOps. So it's really just a case of starting off small and building that trust within the organization.
Great. What have we got? Another question here then. Wouldn't test data management mean teams can share their code without giving away live data?
I think I may have covered this in a previous answer. There are services which you can use, to abstract away your secrets. For example, you can scramble your database data in the whole process of spinning up a new environment. You can even spin up an environment using test data. So I'm just reading that question. I think that may be a colloquial response to another question. I'm not sure if that's an outright question. So yes, effectively, test data management means that you can share code without sharing. You can share the application deployment code without sharing the application data itself.
Okay, thank you. All right, so another one then. And as we get later into these, I guess some of these you've touched on to some of the ideas, but how can business analysts, Scrum masters, etc., use DevOps to support project design through valued development?
Must admit, I'm not necessarily kind of familiar with the concept of value development. I think I think DevOps is I wouldn't necessarily use DevOps as a poster child for project design. It's more a culture. So if you for example, if you're using DevOps principles and kind of collaboration across these business units, that's the main way to do it. So if your BAs are talking to your Scrum Masters, you don't necessarily need to be doing things as code. And I think maybe DevOps is the issue with DevOps is, unfortunately, that it's been twisted by various different kind of people with various different agendas, unfortunately. So the fact that it's got dev in the title generally tends to mean that it's construed as I've construed it to be a software, a code-based kind of tooling. Whereas I'll probably kind of clarify a little bit. I think it can more be termed as collaboration operations, where different aspects of the business, so your BAs, your QA people, your Scrum Masters, it's essentially collaboration, really. It's opening up those silos that I previously mentioned in the slides and making sure that these people are talking directly to each other rather than over the fence. So you don't have to necessarily do things with development or do things with code in order to benefit from the collaboration aspects of DevOps, which does sound counterintuitive considering DevOps has dev in the name. But I would personally argue that DevOps probably isn't the best phrase for that type of transformation. But if you want your BAs and your Scrum Masters to talk collaboratively, then you're probably more talking about Agile and maybe cross-team collaboration rather than DevOps.
All right, so we got two more questions from the chat, and I can see one person's we might have 3 quicker questions on the chat. We'll take 3 questions from the chat, and we've also got a question where somebody's going to ask you with a hands up. So we'll take 2 from the chat, then we'll go to Yvonne, and then we'll come back to the final question there. That'll probably take us to about 9:30. And I think you've already recommended one book, but are there any books or material you would recommend to somebody who's looking to learn more about DevOps? So you'd mentioned this Agile Conversations as one book.
Yeah, Agile Conversations. Obviously, I'm kind of biased because that's been written by 2 of my previous managers, and I have a massive amount of respect for them both as managers and as technologists. So I definitely recommend Agile Conversations. I would also recommend the Phoenix Project, and probably I'm just going to be kind of honest and say Googling. I must admit I've not necessarily learnt by reading. I'm one of these people that learns in the job and learns by doing. So the best way that I've honestly learned is by putting yourself in these situations and learning at the coalface and learning how to do things from people who are already doing them. Obviously, not everybody's going to be able to do that. People are going to be in companies that aren't DevOps focused. People are going to be in jobs which aren't DevOps focused. And as much as job security is a great attribute, you need to look after number one. And career-wise, you need to look after yourself and skill up in areas where you want to skill. So I would never advise anybody to leave a job that is right for them. But if you want to go into a DevOps Agile skill set and your current organization isn't able to give you that, then there's no harm in looking around for a company or for a role which does. So that's kind of it's a very long answer. It's probably not the right answer, but it's that would be my take on it. I'm a very practical learner. I like getting hands-on. I get my hands dirty with things. So and also as well as Agile Conversations, there is and I'm going to mention these 2 guys again. Squirrel and Jeff also have a podcast which is called Troubleshooting Agile, which they tackle a lot of Agile topics about not just implementing Agile, and I do know that Agile and DevOps kind of cross in their appeal and their implementation, but they are not mutually exclusive. You can implement and development and operations methodologies without going into Agile. And I think that might be the next question, so I'll kind of cap that one.
You spotted that one. Yeah, okay. So then the next question then is, how can you be effective in developing, testing, and releasing applications without using Agile?
I think the two approaches tend to go hand in hand. Not necessarily by any conscious choice, but by virtue of the people that end up using them. So because DevOps is a very is a very software engineering driven design principles, you generally tend to have, the more avant-garde kind of Agile development companies using them. Now, that's not necessarily meant to say that you can't do it without agile principles and without agile processes, but they do help. For example, having daily stand-ups may help in the interest of cross-team collaboration. For example, one approach I've seen in the past at one of my previous companies is a Scrum of Scrums. So it wasn't necessarily a Scrum meeting; it was more of a daily company-wide stand-up, where it didn't have to be everybody in the company, but there was an engineering-wide stand-up where each development team, each kind of stakeholder, would send a couple of representatives, maybe one or two developers, or maybe an engineer or two, and that would serve as a global status share within the company. What is this team doing? What's that team doing? And it wasn't necessarily a sprint. There weren't any kind of breakdowns involved. There weren't any retrospectives involved. It wasn't agile with a capital A, but it did help get the communication barriers down, which again is one of the main DevOps principles for me. It's not necessarily about the tools that you use. It's more, for me, about the culture you have and the approach to collaboration and destroying some of these silos that have popped up. So yeah, I mean, you don't have to be using Agile, but generally speaking, you may end up using Agile, or at least some of the principles, whether you kind of intend to or not. They generally tend to creep in because it's just the way these things tend to work.
Okay, thank you. All right, so we got a question from Yvonne, and then a final question from the chat, and then we'll draw it to a close. So thank you. Yvonne, would you like to unmute and you could ask your question? Okay, well, whilst we wait for Yvonne to come to the mic, let's take a question from Mark then. So, where do traditional scripting languages like Bash and PowerShell fit into DevOps pipelines, especially thinking about Microsoft specifics like Windows service deployments?
I think they can be at the core of them. To be perfectly honest, we use Bash pretty much everywhere in our DevOps pipeline. It doesn't necessarily have to be infrastructure as code all the way. So, for example, sorry, I'll just finish off this answer and then we can come back to Yvonne. The scripting languages can be pretty much anything you like. It can be Bash, can be PowerShell, can be Python, can be Perl, can be Fortran. The underlying languages don't necessarily have much of a impact. It's more about the culture and the mindset behind the automation and the collaboration aspect of DevOps. For example, you can have a Bash script that runs all your CI pipelines, for example. You can have a PowerShell script that deploys your Windows services, and then you use a testing framework to test them. So it can, the implementation and the thought process and the design are the two separate entities for me. You can use kind of traditional scripting languages alongside DevOps mindsets and DevOps practices.
Great, thank you. Yvonne, would you like to ask your question? Oh, hang on. So does design play a significant part in DevOps? Are there standards on DevOps?
I would say, I wouldn't say there's any standards, purely because it is a very, that I wouldn't, to be fair, even if they were, I would be very cautious about I would be very cautious about kind of acknowledging any DevOps standards, purely because it is a very widely opinionated environment. I don't necessarily think that there's a right way to implement DevOps, and I don't think there's necessarily a right way to explain about DevOps. I mean, I've attempted. So I think as far as standards go, I don't think there are. This is my very kind of maybe divisive opinion that the job title DevOps engineer shouldn't exist, because I don't think it's. I personally don't feel it's a skill set that you can kind of quantify into a job title, let alone a set of standards. But as far as best practices go, I think the best thing that you can do is try to break down the traditional silos that exist, try to foster good, honest collaboration and communication between your teams, and foster your engineers really. If there's an engineer or group of engineers that want to implement something, then the proof is in the pudding really. If somebody goes off and kind of says I think this is a good idea, then that's reason enough to at least build a POC of it, to test it out, and if it works, then that's an absolutely awesome outcome. If it doesn't work, then people have learnt in the process of doing it. So I think that's almost equally as valuable. But so I'd really say that although there's no outright kind of DevOps Standards Association, or there's no RFC on DevOps, I think the best way of looking at it as a best practice is to focus less on the tools that are used and more on kind of how you use them and how you implement them. To try and make sure that you're breaking down these kind of silos that have kind of cropped up over the last kind of 20 odd years, and try to make sure that your dev teams are talking to your operations teams about their application. Just a very quick example I can give is at one of my previous companies. In the systems engineering team, we implemented what we called a systems monitoring contract. So we drew up a standard status page, and we were in a software company with a few different development teams, and we were transitioning towards a microservices architecture. So we had 3 or 4 monolithic applications, and we were trying to break those apart and implement those microservices. So we, as an infrastructure team, came up with an overarching monitoring contract, which says that if your application publishes a status page at /status and serves various bits of information in a specific format, then you as a development team get free monitoring of that application. So all of our automated tooling would be able to look for that status page, read that status page, and then report via Grafana and via, I think it was CollectD at the time, into our main systems dashboard. So just as an engineering team, we were able to say to the development team, if you give us data in this format, we can make this data very useful for you and very visible for you. So that's just an example of a technology, of a technological abstraction between the application and the engineers. So if you give us data, we'll give you meaning. So it's just a way that kind of DevOps can kind of exist and be nurtured in an environment where collaboration happens, communication happens.
Excellent. Well, thank you very much, Craig. I hope we've answered everybody's questions that's come up in the chat. I tried to go through them one at a time. So an interesting set of questions and great set of responses. And well done, as it says there in the chat. Challenging set of questions. Well done. So that was a great presentation, Craig. Thank you very much for sharing your time with us this evening. And Yep. So Fred's adding some applause there through the Zoom.
Thank you very much. It's been a pleasure to chat to everybody. And if anybody's got any kind of follow-ups or anything, please feel free to ping me. I'm on the ABBA CompSci Discord, and obviously LinkedIn, Twitter, and email. So if anybody wants to get in touch, you're more than welcome to. Excellent.
Well, thank you very much. And thank you very much to our attendees who've joined us this evening. The session has been recorded, so the BCS will be arranging for that to go forwards to make that available. And yeah, well, thank you very much. And you should get a feedback link. So if you've got any comments on the session, or please do respond to that feedback. Thank you very much, Craig. That was excellent.
Awesome. Thank you very much, guys.